Okay, good. Okay, thank you everyone. Okay, so before we start learning about the microprocessor, all right, what's inside there? Okay, let's look about the history, okay, of computer itself. Okay, so as you know that uh, old time ago, right? So it was in I think in somewhere in 19 um, 1970, all right, 1970. Okay, so the size of computer was about as you can say, it's a mall size or a factory size. Okay, so it's very big. Okay, so this is the size of computer like 50 years back. Okay, and then we have, okay, the computer was made from the transistor. Okay, so this is the second generation one, right? So it started in 1956, right? So from the big of the mall or big of factory, then it reduced half of it. So you see how tremendous the technology is. So within the like 5 to 10 years, right? So the people managed to make a smaller computer. Okay, as you see now, even nowadays, um, we have tiny computer. Your mobile phone, right, is also a computer, right? But the chip is very small, so it can include many things. So that's why your phone has so many capabilities. Okay, so you have let's say light sensor, right? The gyroscope, accelerometer, and so on. You have the GPS, you have the Wi-Fi, Bluetooth, and so on. So the company, right, that managed to build the smartphone, right, can include so many things because right now the size of the microprocessor could be made very small. Okay, as you can see that the transistor size, okay, the transistor size is much more smaller than a micrometer. Okay, so this is the third generation. So it's like 4 by 4 square meters. Okay, before that it was half a room. Okay, and then these are the first microprocessors or microcontrollers made. Okay, so it was made by the Texas Instrument TI. Okay, and also from Intel and also from Motorola. So these three companies made the first microprocessors. Okay, as you can see, these are the chips. Right, these are the chips that that you usually found nowadays in your lab. Right, to do some measurement. Right, so you can see that how possible, okay, to make a tiny transistor so you can have a very small microcontroller. Okay, so you see that the timeline, okay, from 1950, all right, up to today, right? So you have much smaller and smaller transistors so that you can make a smaller microprocessor. So why it is important to have smaller microprocessor? As I can say, so you can have uh, a palm-sized device, okay, but it includes many features. So if the microprocessor is big, so the people cannot attach the microprocessor with other sensors, right, to work together with the microprocessor. Okay, so whenever the microprocessor can be made smaller, so all of the other sensors could be fit, okay, into the packaging. Okay, so these are the architecture of the microprocessor and also the microcontroller. So you look there, it is quite similar, except that the microcontroller have some legs. Okay, so you can do the input and output connection from that. Okay, but for the microprocessors, okay, uh, it will be interconnected, okay, with other peripheral devices inside the computer. Okay, so we will learn about this architecture of the microprocessor uh, in the chapter 2 later. Alright, so we will learn more details about that. Okay, so these are the microcontrollers that is used, alright, in your mobile phones, the ARM controller, so on, right, and AVR. As you can see that this is used in your mobile phone today. Okay, so right now you even have the technology up to 64-bit microcontroller. Okay, so this is the architecture of this one type of the microcontroller, the AVR one. Okay, AVR is, okay, we are having a bus, alright? Bus is like a highway. Okay, so let's say RAM is the destination. So all of that, all of here, all of boxes over here uh, are the destination. Okay, it's like your house, right? So this is your house, your friend's house, your mom's house, or your your other friend's house, right? Okay, so the CPU is like um, UPM, right? It's like UPM. You can call it as UPM because you are you are going to meet all together at the CPU, all right? So it's like a main destination, right? So CPU is like a main destination, but here is a much smaller destination. Okay, so the bus is like a highway. So if the information want to be traveled, okay, so you need to go through the bus. Okay, go through the bus and enter the CPU, or from the CPU to the RAM, or to other part of the uh, PC, right? So that's the architecture of the AVR. Okay, so this is the packaging, right? So you have many legs there, but each of those certain legs are meant to be connected, okay, to different connection. Okay, needed it has certain purpose. It has certain purposes. Okay. All right, and then you can see that it also contains multiple different group as well. Okay, so this is just for your reference. Okay, okay, so these are okay. This is the this is a microprocessor. Okay, it's an Atmel microprocessor. As you can see, if you try to open up your PC or your desktop, you can try to look at the microprocessor, and it has an architecture like this. Okay, so these are the pins. The pins are to be connected to the motherboard, right? So to the slot, and each of these pin has certain function. Okay, whether one is go to the memory, or go to the peripheral device, or go to the keyboard, mouse, and so on. So it has a specific function, okay, for each of those pins. Okay, so these are just the different numbers or different technology of the AVR processor. Okay, and then you also have the Arduino. Okay, so Arduino using a microcontroller, okay, on top of its board. Okay, I think you should be familiar if you are from the instrumentation major, right? You will be using Arduino soon, right? To do interconnection with the sensors and so on. Okay, so Arduino is like a simple computer, alright, but it use the technology of microcontroller to do the processing. Okay, okay, so how do you know? Alright, based on the name of the microcontroller, so you know the capability of each of the microcontroller. Okay, let's say the 80 mega. So 80 means the manufacturer of the chip, so Atmel, and mega is the group of the microcontroller, and 128 is the flash storage capability. In that the storage capability, it can fit up to 128K. Okay, also similar to the other one, 80 tiny, K44, 8090 S, K4, 433. Okay, and this one is a bit special. So you look at the port number there. Okay, so it give you the amount of flash is 4K, right? So if you want to know further, so you can go to these references. All right. Okay, so that's a brief history about the computer, right? And then what you're going to learn inside this course is detail about the architecture of the microcontroller or micro uh, computer, right? Or we call that microprocessor as well. Okay, so you're going to know each specific function of how the CPU works. Okay, so what is inside the CPU, what contains inside the CPU, right? How the information travels from um, what you input on your keyboard or what you input from your mouse get into the CPU, and then CPU send it to the storage or send it to the memory, okay, to store that, or even show that on the screen. Okay, all right, so let's move to the second part. By the way, if you have any question, you can let me know. By the way, I'm going to share you first these slides on the WhatsApp group, so you can have that for your reference. Okay, share everything that what should be covered within this semester, so you can uh, go and download the notes. All right. So let's look into the microprocessor technology. We look into the 86, all right? The 86 microprocessor. Okay. So over here, we're going to look into the Intel family microprocessor. So 86 means it covers 85, okay, up to Pentium, okay. And then we need to know what is the execution unit, okay, and bus interface unit, okay, the pipelining technology, right, the registers, okay, and also the code, right, which is the part of the assembly language, okay, where you need to do a simple uh, function within the CPU. Okay, and then these are the later part that we will cover as well, right? What is the little endian, right? Not little Indian, little endian, right? So you will able to distinguish that. Okay, what is the code segment, data segment, stack segment, okay, and then push and pop instruction, okay, and also the flag register, okay. So this chapter is the longest chapter in this semester. All right. So it will take about um, maybe 2 or 3 weeks, okay, to finish this chapter. All right. Okay. So this is just we're going to I'm going to give you a brief history about the 86. What about the 86 microprocessor technology? Okay. So it was introduced in 1978. Okay. So the first 86 microprocessor is the 16-bit. Okay. So it is improvement from 80, 80 and 85 series. Okay. The capacity that 86 has is the 1 megabyte of memory. Okay. Before that, it used to have 64 kilobytes of memory. Okay. So it is actually um, more than double of the memory that 85 has. Okay. What's the advantage of the 86 microprocessor? Because it can process over 16 bit of uh, data, right? Compared to the 85, where we used to have 8 bit of data can be processed on that processor. Okay, so the drawback when using the 85 processor is whenever you have data larger than 8 bit, okay, then you need to wait. Okay, first you need to process that 8 bit. Okay, and then once that finish, and then after that it comes another 8 bit and then do the processing. So it will take much longer time, okay, for the processing to be completed. Okay, and also the 86 is called a pipeline processor. Okay, and then compared to the previous 85 processor, which is non-pipeline. Okay, we will learn more about how the pipeline technology works. Okay. Okay, so you can look at this table. Okay. Um, so basically, you can look into how the technology evolves. Okay, from 8008 okay, up to 8088 processor, and what's changed between the number of pins, right? The technology used, okay, number of resistors, and so on. Okay. All right. So the 86 microprocessor, as I said, we have the 16 bit of data bus, okay, internally and externally. They mean that the registers inside the um, CPU, okay, is 16 bits wide. Okay, so there is a 16-bit data bus transfer data in and out of the CPU. Okay, all right. Um, but the problem, okay, but the problem with this 86 processor is that there is a resistance, okay, to the 16-bit external bus. Okay, as peripherals were designed around 8-bit processor. Okay, so it comes with later technology, but actually the technology is much cheaper, right, compared to the 86. Okay, um, the thing is that the technology during that time is not yet ready. Okay, for the processor to have the 60-bit. Okay, meaning that your printer, your mouse, or your keyboard still using the 8-bit technology. But the capability of 86 is much higher than those. Okay, so that's why Intel make another processor which called 88. Okay, so 88 comes with the 8-bit data bus, but the rest of the features, okay, that contains within the 86 is still in 88 processor. Okay, so because of the so much compatibility, okay, so it's like you are buying a new PS5, right? If you're buying PS5, so the PS5 games, right, is still much expensive compared to PS4 games. So you must make it compatible to be used on the PS4 games or PS3 and so on. Okay, if not, then the people won't buy it, right? Because even though you had the latest technology, but if it's not compatible backwards to the old technology, right, then it is hard for people to use. So it will decrease your sales. Okay, so that's why they came with the improvement. Okay, so okay, why not we just make it a bit? So, but the other features we still retain as long as it can be compatible. Okay, with other devices. Okay. So that's why it was a success for the 8088 processor compared to 86 during that time. Okay. Uh, Intel again introduced 8286 in 1982. Okay. So IBM was copying, all right, this design, right, to make a PC. Okay. PC called the PC80. Okay. This microprocessor, okay, contains 16-bit internal and external data buses, right? And it has 24 address lines, okay, for 16 megabyte of memory, okay? And it also contains the virtual memory, okay? All right. Maybe you are a bit confusing. What is the buses? All right. What is the address lines? What's how the memory works? Okay, we know after this. Okay, how this works together with the CPU. Okay, so these are the operating mode of the 80, 80 to 86 processor. Okay, so it is have a real mode and also protected mode. Okay, so real mode can work faster, okay, with the maximum amount of 1 megabyte of memory, or can be working in the protected mode, okay, which allows of the 16 megabyte of memory. Okay, so what is the virtual memory? Okay, because this processor has the capability of virtual memory. Okay, if you use Windows, okay, you have the function of you can set how much virtual memory that you want to use. Okay. Okay. The virtual memory is actually the space that you take from the storage. You assume that is part of the memory. Okay. Why the computer works with the memory? Because memory is instant, right? You can go. Okay, you can, right? If you want to access it, the memory give you a faster access. Okay, you want to write and you have a real-time processing, it must be accessed from the memory. Okay, not the storage. Okay, storage you want to put like your hard disk. All right, the storage is used to store the information where you are rarely use it, okay, or seldomly use it. Okay, so that's the information that you put into the storage. Okay, for the information that you need to access every second or every minute, okay, that needs to be put into the memory. Okay, so sometimes this memory are not enough, so you need to make a virtual memory to add, okay, to top up of the current memory spaces that you have. Okay, and then we are now introduced with a 32-bit microprocessor. Okay, so it has a 32-bit of address bus. Okay, so you assume that when we have the, the higher bus, that you have a bigger highway, right? So whenever you have a bigger highway, the information, right, like your car, like the highway, right, like the highway, the real highway, if you have more lanes, right, so when you have, let's say, from 2 lanes, now you have 4 lanes, okay, for example. So much more car can travel at a faster speed, okay, because it can change, because if the lane 2 is slow or clogged with uh, many cars, okay, and then you can switch to the third lane or the fourth lane, right? So that's how it works, okay? So bus is like a highway, so when you have a higher bit of buses, meaning that you have uh, a bigger width of the highway, okay? So it can also handle, okay, memory of up to 4 gigabytes, okay? And then the virtual memory can be increased up to 64 terabyte. Okay, sometimes, okay, Intel is always like this. So whenever you make a premium processor, so you want to make a much more cheaper processor with the latest technology as well. So it's like it introduced, say you now have let's say I10, right? I10, and then later you have the Celeron or Pentium Gold. Okay, so that's much cheaper, okay, solution. Okay, so it is reduced a little bit of the performance, okay, but still we have the latest technology because they want to make it affordable, okay, to different kind of group of people. Okay, and sometimes when we do a quite heavy computation with the computer, so you must have a special microprocessor. So like Intel, we have Xeon. Okay, Xeon microprocessor. Okay, it's used usually for the server task. Let's say you are handling, let's say the Facebook. Okay, need to handle so much data comes in, come out, so worldwide. So they need to use a very big computer, okay, with very powerful computation power because you need to process so many data at 1 second. Okay, so that's why Intel was designing those kind of microprocessor. Okay, last time it was called that as the MicroP processor. Okay, so the number is 87, 82, 87, 83, 87. Okay, so that's the a much more premium processor that was developed by Intel. Okay, right in the in the 89, Intel introduced a new microprocessor 486. Okay, so it combined that microprocessor with the 386 processor on a single chip. Okay, plus additional features called as cache memory. Okay, cache memory is static RAM. Okay, with a very fast access time. Okay, mean that static RAM, so the RAM information inside that is not moving, so it's static. So whenever you want to access it, you can access it, okay, without doing the writing or rewriting, okay, of the information inside those RAM. Okay, so all programs written for the 8086 microprocessor will run on 286, 386, and 486 uh, 486 computer. Okay, so these are the evolution of the Intel microprocessor. So you can look further, okay, on the slides given to you. Okay, so how the technology different, okay, from the 86 up to the Pentium Pro. Okay, and then after Intel numbering those microprocessor, okay, it released a Pentium, okay, a Pentium processor. Okay, because what? Because Intel want to make it as a copyright. Okay, so they put a number. Okay, because a number, you cannot claim that as yours. All right, you cannot claim that as your copyright. Okay, is if it is if it is a number, you cannot claim it as a copyright. But if it is an alphabet, you can claim it as copyright. Okay, give me a few seconds. Okay, so on the release of this Pentium microprocessor, okay, it has speeds of 60, okay, and 66 megahertz. Okay, so during that time, it's already using 3 million of transistors. Okay. Okay, so the advantage of this Pentium processor is fully compatible. So this is important. Must make it fully compatible, but added with some new features. Okay, separate 8K cache memory, okay, for code and data. Okay, and 64-bit bus, so much bigger bus. Okay, right, and then it is a package. Okay, so the packaging, so you want to fit into the motherboard, so it has a certain slot name. All right, so if the slot is designed like that, so you must use a microprocessor that is fit, okay, to that motherboard. Okay, so it is using a special uh, chip, okay, design, which is called the PGA. Okay, so this is other features of those Pentium processor. Okay, so this is what I just mentioned. So it designed for a server. Okay, last time Xeon is yet to be introduced. So it was introduced with the Pentium Pro. Okay, so that time the server still using the Pentium Pro. Okay, then later Okay, you have the Pentium 2, 3, 4, Titanium. Okay, before you have that, before this, okay, after that, you have the Core 2 Duo, alright, dual core, right? And after that, you have the I generation processor up to now. Okay, and then, alright. So later part of the technology, Intel was considering so because enhanced people use PC for gaming, alright, and also use for web surfing and so on. So Intel introduced a Pentium 2 processor because right now we much involved with the beautiful graphics and so on. So we must have a highly, very high performance, all right? High performance on the micro processor. Okay. So Intel introduced the features of an MX, right, which is called a multimedia extension. Okay, and then this is the Xeon that I mentioned. So it replaced, okay, Pentium Pro for the servers and workstation. And also Celeron, all right? Celeron was used for lower cost and good performance, okay? Let's say if you want to do a basic typewriting stuff, something like that, not using it for graphics, then Celeron is just enough, okay? And then also later, Intel also introduced the Pentium 3, okay? More enhanced graphics, right? For the 3D graphics and so on. Okay, and also Xeon have the Pentium 3 Xeon. Okay, that's for the workstation. Okay, and then Pentium 4 was released in 99. Okay, with speed of 1.5 gigahertz. All right. Okay, and then it's using a new architecture. Okay, because sometimes the architecture of the chip needs to be improved. So the design, where to place, where to put register, and so on, the CPU must be improved because they want to make a packaging much more smaller, but want to include so many things. So that's why they are using different architecture. Okay, so Intel introduced the first 64-bit microprocessor using a family name, all right, Itanium. Okay, so this was the microprocessor made mainly for the internet. Okay, because you need to use you need to process the data receive, okay, and the data go to upload and download. All right, so you need to have a very high performance computing. Okay, all right. Okay, so let's talk about the architecture, okay, of this 86 microprocessor next week. So I'll stop today for now, right? Sorry, I stop there for now. Okay, so any questions so far? Okay, so any soalan?
Tak ada.
Ada doktor.
Alright, so we will meet physically on after week 3. Okay, so for this week, okay, this is the first week, second week, and third week. So mean that the fourth week we will meet physically at the academics complex. Okay. Alright, so see you guys next week. Okay, thank you. Alright, Assalamualaikum.
Thank you, Doctor.
Thank you,
Waalaikumsalam.
Doktor.
Thank you, Doctor.
Doktor.
Terima kasih doktor.
Thank you, Doctor.
Okay, welcome.